Hi, everyone. So, hi. I'm recording on my new phone, right? I got a 14 Pro. So it looks way different than the setup of my other one. So I just literally got it yesterday. So I'm trying to figure out the schematics of it. So really quick video, or I'll try to make it a really quick video. Today we're gonna talk about law of signs with ambiguous cases. That just means that we could have a couple of different solutions here because it's not clear until we figure it out mathematically how many different solutions we might have, or even if it's a triangle or not. So remember the law of signs, we're still dealing with the law of signs, sine of A over A equals sine of B over B, and sine of C over C, where the capital letters are angles and the lowercase letters are sides. Now, let's get right into it. Your worksheet today, I'm actually gonna take two problems off that worksheet, so hopefully you'll be able to see this okay. Number 5 here. So this is number 5 on your worksheet. So it's giving you pieces of information and it can't give it to you in a diagram because we don't know if this is a triangle or not. So why would it draw a triangle if it's not one, right? So obviously, spoiler alert. It's hard to say in the morning when you're tired. This will not end up being a triangle, and here's why. So if I give you the measure of angle C, and that's 128 degrees, I'm giving you, my face is like right here, and the phone's not even that close. Okay. Side B is 35. Who cares about the unit? Side C is 32. It wants you to find side A. Now remember, we can't just do Pythagorean theorem because these are not right triangles, okay? So we're gonna set up our diagram. And again, the diagram's not there, so you have to draw one. Just draw any triangle, it's fine. A, B, and C in order, and then it's gonna be A, B, and C the other way around. We talked yesterday about, the side measurement will be directly across from the angle measurement. Okay, so I drew the triangle here and I labeled my sides and my angles. So again, these are SSA angles, which is the donkey theorem, which is, it doesn't prove that it's a triangle or not, right? So we labeled our sides, and again, we're trying to find side A. So because I have a C angle and a C side, and I have a B side, I really want to find A, but I can't do that yet until I find angle B, right? Because I'm not allowed to find anything with A if I don't have an A measurement. Now, I can't find the angle of A yet anyway because I only have one angle, right? If I had two angles, then I could just completely subtract it to get angle A. So we have to go one extra step to find out B, and then I can subtract them. Now, when we talk about answers being not a triangle, this is actually gonna work out really nicely because I don't have to go any further. Here's why. So I'm setting up my law of sines. Again, I'm using sine of angle C, which is 128, divided by 32, which is the side measurement of the side C. And then I'm gonna equal that to sine B, which I don't know, because I'm trying to find that in order to get A, over 35, because I do know that the side of B is 35. Okay, so I'm gonna cross multiply, and I get 35 sine 128 is gonna equal 32 sine B. Okay, still good, right? Now, this is me just doing the cross multiplication. 35 sine 128 is gonna be 25.24. Sidebar, make sure you're in degrees on your calculator. It's not gonna work otherwise. Okay, the rounding part's gonna be a little messy. So if you get something that's really close or in the vicinity of the answer key, I'm totally fine with that, right? It's when you get things that are totally wrong or you tell me it's a triangle when it isn't, then that's gonna be weird. Okay, once I make this calculation, I'm gonna get 0.789 for sine B. Now, because I'm looking for an angle measurement, I'm gonna have to do the inverse of this, right? So the inverse of that will give me what the measurement is of the angle. Now, if I wanted just the side, it would give me a value that would be indicative of a side. Like 0.78 does not even look remotely like a side measurement. I want to make sure that this goes down a little bit. Okay, that's not what I wanted. Sorry. Again, new phone. Okay, so I'm going to do second sine of 0.789. That's going to give me 65.3 degrees, which is the measure of angle B. Do you see what the problem is here? No pun intended. You just see, right? It's not actually A. Well, if this angle is 128, how can that angle be 65.3? That means it's not a triangle because both of those angles added up is more than 180. Even if they were exactly 180, what about the third angle? That's only two angles, right? So that right there means it's not a triangle at all. So your answer is actually not a triangle. So that information doesn't give me a triangle. It's just blah. So those are the non-triangle ones. The other one's a little harder because we're gonna have ones that have two solutions. Okay, I'll try to explain this quickly because I kind of have to go to, places. Number six, again, spoiler alert, it's gonna have two possible solutions, and there's a reason for that. So I'm gonna try to explain it as fast as possible, but also efficiently as possible. In this particular problem, I'm giving you the measure of angle B, which is 71 degrees, and I'm giving you A and B. Remember, these are SSA triangles, so two sides and one angle. This one wants me to find side C. That's a little c. I know it's hard to see. Get it? Okay. Drew my triangle, 71 degrees for angle B. I got my two side measurements, A and B here. Now, I set up my equation because I have both B values. I have an A side, which means I'm going to have to find that angle of A first before I go to anything for C. I don't have any measurement for C, so I can't find C yet. I have to find A first in order to get C. So when I set up my equation, here we go, I just kind of worked it out. Now, this is actually really important. So I'm getting sine of B is 0.979, and that's not the bad part. The bad part is here. Second sine of 0.979, when I do that for the inverse, I'm going to get a value of 78.5 degrees, which is the angle measurement for A. So sine of A is 78.5 degrees. Now, here's the problem. The problem is in triangles, the sine measurement of one angle is going to always equal the sine measurement of an opposing angle, right? So it's complex, right? But when we talk about the relationship between cosine and sine, well, cosine squared plus sine squared is going to equal 1, right? And that's part of the unit circle. More on that later. But when I get a measurement that does fit, meaning the 71 degree measurement and the 78.5 degree measurement do not equal 180, like there's still room for another angle, we've got to make sure we do the sine measurement of that other possible supplementary angle, because the supplements will be always the same. For example, let's say I had a triangle and the sine of one angle is 60 degrees. Well, the sine of its other supplementary angle must be 30 degrees, meaning they're going to be the same measurement, even though they have this different angle measurements. It's complex. Again, I don't want to waste too much time. So because I've got this 78.5 here, I'm going to go ahead and calculate what's going to happen, or what the side measurement for C is going to be when I input this in here. So we're actually going to do this twice. That 78.5 is going to go in here for A, which means I'm going to find the measure of angle C. And the measure of angle C is 30.5 degrees. Now I can find side C. So when I use, and I can use any measurement now because I have a lot of stuff here. I think I used the B's again, and then I used angle C. So I would set up sine of 71 over 33 equals sine of 30.5 equals C. And that's going to give me a value. And that value is going to be, where did I put that value? Your answer key says 18.5, but I got about 17.9, which is fine because I rounded not the same way that they rounded. Okay, so we're in the vicinity, and that's fine. So that's one possible solution. Sorry, that's one possible solution. Now, remember what I said earlier. If one sine measurement has a supplement, well, I need to know what the supplement is. So what I'm really doing here is I'm doing 180 minus 78.5. Which is going to give me the other value, right? So that's going to give me 101.5, which means 101.5, the sine value of that is going to be exactly the same measurement. And here, I'll give you proof. Sorry, calculator. I'm not using this calculator. No. Okay. See that? So the sine value of 101.5 is exactly the same as the sine value of 78.5, and that has a lot to do with obviously the domain and range of these functions, right? Because there's a constraint. Like it can't be this. It can't just keep going and going. It's because trigonometric values are circular, right? They're cyclical. They keep going around. Anyway, here's the proof. I didn't lie. So we always have to find the supplement. So when, again, really important, when we find an angle measurement that works, meaning I have more room to find a third, I've got to do this process twice because there could be two possible answers to this. Okay, anyway, so when I put 101.5 in here and I subtract out to find the third angle, I get 7.5, which is really, really small, obviously, right? I'm going to do the same process because now this is the missing angle. I'm going to do the sine of 71 over 33 equals sine of 7.5 equals C. So my second value is going to be, and your answer key says 3.6, I got 3.2. Okay, again, I only did it because my rounding wasn't the same as the worksheet. So if your rounding's not perfect on the worksheet, it's totally fine. I'm good to go. It does say to round to the nearest 10th. I did not. I rounded to the nearest 100th. So that certainly makes a significant difference in these problems, okay? So again, really quick recap. What are we doing? I don't know. No idea. We're doing what's called ambiguous cases. This is really close. Get back up. Okay, we're doing ambiguous cases of triangles. You're gonna have three potential answers. You're gonna solve all this stuff and you're gonna realize it's not a triangle. So that's one possible answer, not a triangle. Our second case here means because angles will work in the triangle to make a third angle that works, you're gonna have two possible solutions. Now the third case is there will only be one solution. And the reason for that is because when we plug in our value that works, when we did the supplement of it, it's gonna end up to be error domain or no solution. So when it comes to no solution on the second try, or even the first try, you're gonna realize that there's only one solution. So it's either 0, 2, or 1, okay? Longer video, but really important concept. There is a short worksheet, there is answers. You can text me on a remind. I don't know if I'm able to get it today, but hopefully, if you keep your fingers crossed, I will actually be in school tomorrow, all right? Miss you, bye.